So if you have one of these, the 1U4s are fine. Now this has an advertised range on inductance. Well, first of all, let's take note of what it says here. It gives us the range of resistance 0.1 ohm to 10 megohms, 100 picofarads to 100 microfarads, 100 microhenries to 100 henries, and I'm trying to find where it says precision accuracy. 1/2 of 1% decade resistors are used. Now they're not saying the accuracy of the bridge is 1/2 of 1%. They're saying 1/2 of 1% decade resistors are used. 1/2 of 1% silver mica condensers are used. And then it goes on, accuracy is limited by interpolation, blah, 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 blah. And down here it says, accuracy will fall off at extreme outer limits. Okay, outer limits. So, what does that mean? Well, it means that when we're testing a 100 microhenry choke, it's very difficult to get a null on this bridge at all. And in fact, I am using the external detector jacks and an external oscilloscope to measure the null in the bridge, because it gets so vague on the meter at the extremes that it's almost impossible to find the null using the microamp meter. I have also connected an external oscillator here so that I can operate the bridge at 50 kilohertz or 100 kilohertz or anything in between. You know, I can dial in whatever frequency I want to inject into the bridge to try to get a little more accuracy out of the capacitance and inductance readings. And it does help at the extreme ends of the range. As the unit sits at the extreme ends of the range, it isn't very useful. And I have been through this upside, downside, inside, outside. And before anyone says, oh, it's probably those 2 wax capacitors you left in the bridge circuit. No, it's not. And I'm not going to go out and buy expensive polypropylene, 0.5% capacitors just to prove it. It's not worth it. By the time I get through working on this, I'd have $50 to $100 tied up in it. And for the guy with the $10 test bench starting out, $8, he can have all the functionality, more range, plus additional functionality. And again, I hate saying that, but that's the way to go if you're just starting out. If you're a collector, these are nice to have on the bench. It's a nice looking piece of nostalgia. But not much of a bridge, I'm afraid. Okay, let's get on with it. Here's a 35 microhenry inductor. I can't even get a null on this bridge with it. If I connect it to this guy, it reads 37.6 microhenries. And it reads 35.6 microhenries on my Boonton laboratory bridge. This won't even measure it. But let's go to its advertised or published spec. This is 100 microhenries, and I know it's exactly 103 to be precise. So we'll hook this thing up to the top of the bridge. I'm going to set this for internal. That uses the internal meter. I will set it for internal oscillator. It uses the 1 kilohertz internal oscillator. Then to set this up, you zero the generator level. Then you zero the voltage amplifier for the meter. Then we turn up the generator level until we get a reading. Now we're probably not going to get very much of a reading because we're at the end of the specified or published specifications for the unit. So the unit is struggling at 1 kilohertz to give us a reading through the bridge with that inductor. Now I know it's 100 microhenries, 103. So there's a 100 microhenry scale, or range, excuse me. And I'm going to look for a null. Oh, I'm sorry. I'm talking and not paying attention. I was on capacitance. This is inductance. So there we have. We're on the 100 microhenry range. There's a peak something there. Whoops, I'm going to sneak up the meter level and see if I can find a null. And I'm seeing something somewhere around 110. Yeah, let's see if I can get a little more. No, I can see that right around 100 I'm getting a bit of a dip there, but it's nearly invisible. So I'm going to go to external, and then we'll take a look at the scope over here. There you can see the null quite clearly. And if I dial in the Q, and I dial in the null, and dial in the Q, and dial in the null, this says it's 104 microhenries, which is, well, actually no, it's 103.5, which is pretty close. But you'd never get that without having an external oscilloscope hooked up. Now I can also go to external oscillator and turn this. Right now this is operating at 70 kilohertz, and see if we can get any improvement on the null. A little bit there, a little bit there. That's an improvement. Okay, this is now, it's saying it's exactly 100 microhenries. So which one do you believe? It's up to you. It's well within useful measurement range. The upper limit is supposed to be 100 henries, and I don't have 100 henries. I do have a 20 henry choke. So I'm going to go back into internal, turn down the gains, and we'll put a 20 henry choke on it. It should read that with ease. And we'll swing back over here. Now if we watch the meter, I am on that's 100 microhenries, 10 millihenries, 100 millihenries, 1 henry, 10 henries. So I know it's a 10 or 20 henry choke, so I'll just look for it somewhere in that range. And I'm not seeing an actual null. Let's set this up correctly. That's zeroed. We turn the gain up. Okay, I'm not seeing a full null there. That's better. And this is showing it to be approximately, now let's get the Q balanced out. You can see it's a little bit fidgety to play with. We'll turn the gain up again. We get a pretty good null at the high end of the range on the inductance readings. So we can be pretty sure we're hitting it pretty closely here. And that's telling me I've got 19.5 henries, which is close enough to 20 henries to be pretty sure that that's a 20 henry choke. So useful there, I suppose. Then I tried to use this with a 150 microhenry choke, or coil, inductor, whatever. If I put this on here, we're going to go back down to the 100 microhenry range. We're on internal. I'm going to turn down the oscillator, zero the meter, bring the oscillator up, and see if I can find a null on what I know is a 150 microhenry inductor. There's a null. And I can't find really a discernible null that makes sense here. If I go to external and we look over here at the scope again, remember, this is supposed to be 150 microhenries. And this is reading about 180 microhenries. Now, the standard frequency used on most bridges is 100 kilohertz. So I'm going to go to 100 kilohertz, go to external on the oscillator. So we're using the external oscillator as our source. There we go. Now we have a null. A real null, a readable null. And this is telling me it's 150 microhenries. We're on the 100 microhenry range, 150, 1 and 5. So does it work? Yes, but it won't work at 1 kilohertz. You have to inject a frequency that's more suitable for testing small inductors to get a decent null out of this thing. And I know this is pretty much accurate as far as the value marked on it. I've tested these with my other bridge, and they all fall around between 147 and 152 microhenries. So the fact that this is reading an actual 148, 149 microhenries, pretty accurate. But you're not going to be able to use it without an external oscilloscope and an external oscillator. Capacitance. Let's move on to capacitance. Let's not waste a whole lot of time going through here. Now, the published range for this is 100 picofarads. And I have 100 picofarad here somewhere. That's 47. Here's 100 picofarad. So I'm going to change this over to capacitance. And we'll go internal, internal. Turn the gain down. Zero the bridge. Bring the gain up, put our capacitor in here, bring the gain up a little more, and that's 100 picofarads, so we want to be up on the other end, 0001, and I've got a null. A fairly readable null. Not bad. I can fairly, see that fairly clearly, and it says it's 110 picofarads. Now I know it's 100. It's actually like 107 picofarads. And yeah, maybe if I look at this without the parallax, it says 109. Not bad for accuracy in that range. If we go to external on the detector and use the oscilloscope, we can probably get that a little bit better. And we have it. Now it's reading a little bit closer to 107. Right around 107. Pretty readable. Now if I come right off the peak, you can see on either side where the null is. So it's fairly accurate at 100 picofarads. And knowing that the range is 100 picofarads, remember it would not go down to 35 microhenries, I figured I'd try going a little bit lower. Or quite a bit lower, actually. Here's a 4.7 picofarad capacitor. Now it gets a little tricky because I'm going to go 0 and I'm going to be reading strictly off of this scale to get to 4.7 picofarads. But the trouble is I've got no capacitor in here at all, and you can see on the scope there's a null. And that null is right around 5 picofarads. So that's internal capacitance in the unit. There's not much you can do about that. It's all the associated wiring. There's no way to null it out unless you reset the dial, and then the other ranges would be off. So what I'm going to do is I'm going to call 5 picofarads 0. Then we'll put in our 4.7. And this is just to show it is usable down here, even though it's published as 100. And then if I null again, see if I can get anything better out of the null. And that's saying 5 picofarads. And it's a 4.7. I know it's accurate. It's a 4.7 picofarad cap. It's reading 5 picofarads. Pretty close. But you have to remember that 5 is 0 and then add as you go down the dial. So you can actually use this for capacitance readings well below the published value, down to 5 picofarads. And that's on the internal oscillator, by the way. If I go to the external oscillator and turn the gain up a little bit, we may even be able to get it closer than that, because now we're operating on a frequency that is normally associated with testing capacitors, 100 kilohertz. That's what most commercial bridges use. It's pretty much the same, actually. Not bad. So it does all right with the internal 1 kilohertz oscillator on the low end of the capacitance range. Now, you remember the inductance fell apart on the low end of the range. Well, the capacitance falls apart on the upper end of the range. It claims it will read 100 microfarads. Or excuse me, is it 100 microfarads? Yes, 100 microfarads. Here is is this the 10 or is this the 100? This is a 10 microfarad. So I'm going to put this one in here. I'm going to go to internal on everything. Swing back over here. So we're on the 10 microfarad range. 10 times 10 would be 100. Or excuse me, it's a 10 microfarad. That's 100 volt working volts. So 10 times 1, we should have a null there somewhere. So I'm going to zero the meter, turn the gain up. It barely comes off the peg, and I mean barely. And I can't really get much of a, okay, there we go. If we go up to the end of this range, that's the 1 times 10, so that'd be 10 microfarads. Turn this up a little bit. And I can see a null there that reads about 9.4, and I know that measures 9.7. So not bad, but the null is really not very distinct. You really got to look for it. Again, if I go to the external on the detector, and I can dial this in a lot closer. There, I've got a good null. Now, let's go to the external oscillator at 100 kilohertz and see what we've got. You see, I'm slightly changing position here. Remember, I said this was a 9.9 microfarad capacitor. And let's see if we can keep playing with this null and get it any better. So this says now it's 9.7. So that's a little bit closer, running it at 100 kilohertz. Is it important? Not really. But without the external oscillator and without the external detector, finding that null is almost impossible. As you can see, the meter is hardly moving until I get way off of the range. So when it gets down to those last couple of, the last little bit of finding out what this capacitor measures, easy for me to say, it's a little more difficult. Now, does it matter at 10 microfarads if it's really 9? Not really. But you can see what you have to go through to do testing, where if I want to test it with this, I simply connect it. What's this one? Is this the 10 or is this the 100? Here's 100 microfarad. I clip the leads on. Oh, should be over here. Push the button. Let's see what this says it is. This says 91.8, so let's call it 92 microfarads, this capacitor. And it's simple. You clip the leads on, push the button, you have a reading. Let's put this in here. For some reason the camera beeped and it stopped recording. I hope I got the earlier part. The battery level's fine. I don't know what happened. Is there a timer on this? Can't be. Anyway, let's there's 100 microfarads. So 10 times 10, Actually, it's going about 8 right now. Yeah, I can't even. I guess there's a null there somewhere. It certainly isn't very discernible. Let's go to external. Again, this is at the 1 kilohertz. Yes, we're on the internal for the oscillator. I try to keep everything in frame here. Yeah, I can't even get it. So let's go to 100 kilohertz. So at 100 kilohertz, this says it's 9 point. Yeah, can we get any more out of this? I'm going to try dropping the frequency, get some more gain out of the bridge. There we go. So we're at, well, there's 50 kilohertz. And this says it's 100 and, or excuse me, 90, not 100, 92 microfarads, which is pretty close. But we'd never get that reading without having a 50 kilohertz oscillator and an external detector. So there you have it. Unfortunately, sadly, if you're on a budget and you want a decent piece of test equipment, this does a very good job with the resistors. I've done a review on these already, so I'm not going to go into all of that. But this will test all your transistors, all your capacitors, all your inductors, and your resistors. I'm not going to bother doing resistance on this. Everybody has a cheap VOM in their shop. Or, you know, you can pick up a volt ohm meter anywhere. A lot of them even have capacitance reading on them. But it's so much easier to use an ohm meter than it is to use this to measure resistance. So that's it. It came out looking decent. It does function, but it does not stand up in today's world against anything that you might want to put on your bench, sadly. If you want one for collection purposes, they're great to have. Nice looking piece of gear from the 60s. I'm the radio mechanic. Hope somebody found this useful or interesting or both. And to the trolls out there, at least thanks for watching. Talk to you later. Bye.